I sit and wait. Does an angel contemplate my fate? And do they know the places where we go when we're grey and old? 'Cause I've been told that salvation lets their wings unfold. So when I'm lying in my bed, thoughts running through my head, and I feel that love is dead, I'm loving angels instead. And through it all, she offers me protection, a lot of love and affection, whether I'm right or wrong. And down the waterfall, wherever it may take me, I know that life won't break me. When I come to call, she won't forsake me. I'm loving angels instead. Hi, my name is Bob Greenyer, and I'm a volunteer with the Martin Fleischmann Memorial Project. So thank you for joining me here on this 5th of March 2023, when we will be discussing Ode, Another Dimension. So, did you hear that? Let's see where you're at. Okay, hi guys. Whoa, well, this has been a long wait coming. It's a little bit messy again. There's going to be bits all over the place. I'm sorry for those people that have been on this journey these past 10 plus years. It will be easier for those that are coming in at this video. Might I suggest that you look at some previous videos for the project, but essentially this pulls together a huge amount of material that led to the realization of a structure which I think by the end of this night you will realize, maybe I could be wrong. I could quite likely be wrong. I've been wrong before, but I think that it will be self-evident that this is the structure that gives access to the God's toolbox. It's been very interesting this week because I reshared data that I was trying to make obvious last year in my Azizi presentation and so forth at the meeting with the Russian community. And then I did a short follow-up with some spelling it out in very, very simple terms and keeping it quite short and brief. And then something very interesting happened. One Melvin Miles, who worked with Martin Fleischmann for a long time and you also worked at the US Navy, requested all of the EVO documents from the MFMP. I don't know whether he knew that I would be the person that authorized the downloading of those, but that happened. And then the following day, Edmund Storms did the same thing, who worked at Los Alamos National Laboratory and worked on the, I believe, the nuclear rocket. But these are the two of the most upper echelons of the LENR field. Two people I greatly respect and admire. I hope that it isn't in an effort to discredit what is going to come. But the clarity, I believe, of the ultra experiment and the simplicity of it, and the fact that it would appear to be both tearing matter apart and making it into new matter and pushing it through a wormhole. And here I want to give credit to one Matsumoto, and this is Matsumoto's book, and I will hopefully be seeing him shortly for a week, and you will obviously have updates about that when that happens. But in the conclusion of his work, he said that a toroidal structure of some type forces material into a point of electronuclear collapse, and that whatever it is goes through a wormhole a distance, and then it starts to come out, and then around the outside you get certain elements, and in the core you get other elements coming out of a white hole structure. And you can go and see that in his book, and I don't think he's too far off. But what we're talking about here is vacuum engineering. And I think in the second presentation, which I encourage you to join me for at the beginning of the day here in Europe, after this presentation, I will be going through an explanation. Honestly, it kind of blew me away as things came together, really. And it is my deepest honor to be able to share this with humanity. I had an image I drew from my I guess from about the age of 5 through to about 20. And actually I drew it on my calculus paper, which was about an hour long, and I did my calculus paper full marks in 20 minutes, and I thought, I'm bored, I'm going to draw my usual picture. And my usual picture is 2 pyramid-like objects, and there's like a cloud and a sun in the sky, and kind of some squiggly thing coming towards me, and a saguaro cactus. Okay, and I knew at some point in my life this would be an important thing. I always thought it was a pyramid, but you know, I wasn't aware that there were saguaro cactuses in Egypt, at least not on the Giza Plateau. So I didn't really know much when I first started drawing this image, whether I didn't know much about pyramids anywhere else. But so I've kind of been on a lookout for that image or something similar to it all of my life, actually. And it was at 2 o'clock in the morning last night I found an image, and we're going to talk about that in the next presentation. But it isn't the full image, but it's damn close, I have to say. But it speaks to the fact that there has been an active, what I would call book burning. And so a lot of my recent O-Day presentations have been about historical documents in the form of masonry. We're not going to be talking about that in this first presentation. This first presentation is going to be going through a whole bunch of physical data that was observed over the last best part of a half decade, more than half decade, 6-7 years, I guess. And it's not well organized, so I'm just going to go through, and I think you'll see the pattern emerging. And that led to the structure in a 2D way, but it was the 3D thing happened in my head very, very quickly, because I've been doing 3D graphics since I was, I think, 15 or 16. I was the first registered trainer of Lightwave 3D in the UK when I was, I think, 20 or 21, I think. So that is some 39 years ago, 29 years ago. So it's very easy for me to do these things in my head in 3D. And so I've just been thrashing that out over the last week and a bit. Finally, something I wanted to get round to. And combining that with the actual data from the physical data, it just blown me away at how nature... it may not work like this, I might be wrong, but I pretty much think it works like this. And we are talking about vacuum engineering. And as I said to you before, I believe that for those people that get what I'm going to say tonight, it will be self-evident to them that we are not the most advanced people to have lived on this planet. And it is something that any sentient species could work out if they cared, but we will get on. So how is everyone? Can people hear me? Okay, so hi Martin Kemp, hi Polygon, hi Corky Goss, hi WP for Truth, John Watson, hi Exotic Propulsion, hi C.I.C, hi the Bippo5, hi Rob, great to have you here, hi Artifact, hi Space Case, hi Alex de Castillo. We got a really good quorum here. This is hi Corky, great quorum here. So thank you very much for taking time out on your Sunday. Hi D2105K. Hi Steve Bannister. Hi Stuart N. Excellent. Hi LENR for you as well. Excellent. So great to have you here. Hi Ken Pratt. Hi David Oates. Okay, so we are going to be talking about this here, my friends. And it's going to be... if I could spell it correctly, I'm just going to go to the next slide and correct the spelling. Like I say, it's a bit of a mess. Okay. Evidence. There we go. Now, we're not going to do everything today, but we're going to do some stuff. I think it will be enough to make very, very clear what I'm going to share with you in the second part of tonight's presentations. Okay, so give me a second. Right. Okay. So we're going to be talking about the evidence. I'm going to be showing you a whole bunch of evidence from a whole bunch of different presentations, and then I'm going to derive the predominant form from that, and then show you how that fits the evidence. And then I'm going to talk about toroidal variations, and then I'm going to show you that just as it was said by Loshak, was said by Perovostikov, as it was said by many authors. I'll get there in the end. Roitskiev, as it was said by Bogdanovich, as it was said indeed by Ken Shoulders. This is a monopole, and you will know implicitly that this is a monopole. It can only be a monopole, or at least parts of these structures, when they get into a certain state, are monopoles. It supports the statement of Tom Bearden that John Hutchison's work, the effects were caused by the aggregation of monopoles in there. I didn't know that at the time. It was when I reported to John Hutchison that I believed that monopoles were doing the work. He said, oh, yeah, that's what Tom Bearden said. So it is monopoles. Some have said that if the monopole was found, then it would be as significant as the electron. I believe that it is way more significant than the electron. It's a virtual monopole, but it is a monopole all the same. And one could argue, is an electron something, or in its own right, or is it made of something else? And if that's the case, then it's all made of the same stuff anyway. So it's just a configuration of the overall something that makes the monopole of an electric charge. And in the case of a positive electric charge, that would be a proton, or a cluster of matter that is net positive, and you have charge clusters which are net negative. So therefore I don't think we should get too specific about saying a magnetic monopole should be made of a single entity, because it's all made of the same stuff anyway. And I think that we can also state with certainty, I believe, that it also has a gravitational component, and one could argue that that is relational, as I have said, to the toroidal moment or magnetism in its own right. And so there we go. I think that will be settled tonight for those that have been following along. Okay, so I'm going to go back here and I'm going to start pulling up a whole bunch of stuff which you've seen before, and I need to have explanations for. So the first time that I introduced the concept of the it being the monopole and that it was this universal thing, I chose very, very specifically this potentially 3100 BC libation disk. So this is 5,100 years ago. One might argue that this is even older than the pyramid itself. So you've got the car, the spirit or whatever, going in and flowing in and then coming down into the this area which flattens out and spreads out. Okay, and I was very specific about this, and I talked about the fact that this lower part here is essentially the same form as this, and that the area from the loop down represents the key to all hidden knowledge. Okay, so I don't need every slide from here. So I talked about this. This is ball lightning coming out of an exploding metal foil by LENR. He showed using iron 57 and north and south magnets on the back of it that there were two types of material that could be aggregated into iron 57, and using NMR they determined that it was changing the fine structure or whatever it is of that nucleus, and so there must be two types of magnetic charges that are being able to aggregate. And they also, in this paper here, they showed that when the ball lightning occurs, it then, after a short period of time, breaks up and it goes into miniature ball lightning. Okay, so that's it. So there were magnetic charges here. The magnets were set at a distance, and so that's how they determined that. There's this paper from 1983 by John G. Kramer, and says basically the monopole could catalytically cause matter to fall apart, which is an interesting thing to say. This was the first time I saw something, these iron-rich crenellated spheres, and it was in the Nova reactor, and I believe that was back 25th of the 8th, 2017. So this was my first interaction with seeing these things being formed. Now, we actually did the experiment in Hungary, in a little bit outside Budapest. Unfortunately, the person that made the reactor has since died, and this is something that haunts me. But anyway, the thing that was very special to me was that on the one side there was kind of like a hole, and on the other side there was another kind of hole, but it was filled with a sphere, it would seem, of carbon. And what I never understood really, and there was something similar going on the big sphere, is how on earth could there be something on here? You know, and this is before I found out that these spheres are genuinely or generally hollow. And the other thing, and literally I've just noticed it right now. I have noticed this for the first time, literally as I'm looking at it right now. This sphere has a hole in the top of it. And we're going to be looking at a lot of those. And so literally, I'm no word of a lie, I have literally just seen that. I've just seen that. Okay, so oh my god, honestly, this is just madness. Okay, so there is a hole in the top of this sphere. So I think we can say that probably these are hollow. Okay, and in that case, it's the same thing as everywhere else. And I believe that we will have an explanation for the first time as to what this hole and this sphere of carbon here is for and how that occurred. And that's really quite spooky, having seen that just now. So I talked about the low shark monopole here and how that relates to sunspots and magnetic activity on the sun. We are going to look at this very, very important experiment, the original lion, And we are going to look at an aspect of it. And what this connector here is doing is it's taking these two pieces of Cantal wire, and it's two solenoids. And notionally, one was a control and one was the active side. In fact, the last reactor that I have on the desk here was actually two active cells. But anyway, if you can imagine, there is a solenoid running down here and a solenoid running down here. That means that either this has got a north here and a south at the other end, or it's got a south here and a north at the other end, and vice versa here on this side. And that's because of the magnetic flux going through the core of the solenoid. So this is running north to south, and actually these are soft iron. You can see these neodymium magnets attached to these bolts, and that would be effectively an iron core solenoid magnet. Okay, so there will be a reasonably focused magnetic field running through this. This will be extremely important for the second presentation that I'm going to be giving today. But it comes down to the clarity of which you need to understand that what I'm going to say in the new day, it has to be that way. It has to be that way. And so then we saw these two spots here, and we saw they were mirrored. So there must be like at least two, but it seems to be these two structures. And the further they move apart, the less they point at each other. So there's something that they point at. But that wasn't all we saw. We saw these flux loops at different angles here. So there were those. And these effectively are... I thought these were rings that go all the way round, but they're not. They are ends of monopole structures. And they do shift material. Okay, these are monopoles, but they are self-organized, and then they're moving around, and you'll notice that the one down here in the bottom right is the one for remote view upside down. And for me, that particular one there showed the sphere, the hole in the middle, the torsional component coming out, and the material either moving in or moving out. And so this was the basic structure at the time. I now have a more specific form of the 3D structure, but this for me would explain what we saw here. And we saw two types, and we saw that the individual types of the same kind can actually interact, and we could see that they were interacting because when you have the overlaid area here, there is no damage. So that means that the spin is going one way and the spin is going the other way, and they're basically cancelling out in the middle here. These are the other type of monopoles, and they are kind of like south monopoles, so they're ramming material into the quartz, whereas there's no effect on the middle here. Now, for those people that are watching this presentation for the first time, or these presentations, I will refer to experiments in a 4-letter moniker, okay, abbreviation. And these are the LION experiments. So if you go to the Martin Fleischmann Memorial Project website, the YouTube channel, and you search for, say, LION, then it will give you all of the presentations that are associated with LION, and you'll be able to learn a lot about it. So here's two monopoles coming together of one type, and here's two monopoles coming together of another type. So we talked about that at length. Right, so the first two that were very, very, very important in understanding things was, this is the first one. Now, why is this important? Well, it shows that you have, this is again from LION, so I'll move my mugshot out of the way. There we go. So this is from LION. And you've got this kind of hexagonal structure on the back here, and you've got this 120-degree cracks in there going into the center. This implies 3 structures around it and the gap in between. But you also have this flux connection between the two here. So this is the first time where I was trying to rationalize what was going on. And essentially, as far as I could see in my head, this had to be, and I've lost my bit of string here. No, it's over here. I've got a piece of wire here. Okay, there, here. Okay, so what that was is this. We have It's not going to work for me, is it? I'll go back to that picture. Someone play some whole music. Okay. So kind of what you've got here is you've got some kind of clustering and some charge separation, and this is a large macro quantum object, and what you're seeing is something like this, okay, and that silvery color thing on the back which is probably copper oxide, and that band which is joining the center to the center is the wormhole, which is kind of like not a wormhole anymore when the overall structure collapses. So that's what you're seeing here, this connection here. I think that's probably copper oxide. This is, this is fused quartz. Anyway, the point that I'm making here is this is coming from the inside out, and then this is the smooth quartz on the outside. It didn't burrow all the way through. And this is the material that you're seeing the damage, but you're seeing the damage through the smooth quartz surface here. But the interesting thing is that it was precisely in line with the center of the solenoid here. So as I showed you before, here, it was burrowing its way through here. And in fact, I'm going to go and get a better image of the kind of part of the reactor that it was, if I can find it. Where is it? I think I put it here, didn't I? Because it's in Seek and Share. Let me find it here. Don't go away. Okay, so here is the reactor, and where it broke, it was 100% affected, and you can see these, the Sothic triangles on the break line here. But it's this area here, which you can see, it's kind of like in the background, you can't quite see it looking through. It was 100% in line and straight in line and 50% down the structure, okay? And so if I go down to the next line, you can see more of it here, okay? So, and it's a slightly different view, and you can see the sort of cauliflower type look here. Okay, and that's a close-up of that. Okay, so this showed me that something is coming from the inside. It's perfectly in line with the B field running through the solenoid, and it's able to consume quartz. And on the backside, it has this bizarre kind of structure, which is showing us here that there is a link between the center points of the backside here. Okay, all right. Now the second one, which is not so relevant for what we'll talk about later, but it is about the field shape of these things, was this one. And the reason I'm saying that is this is standard sort of hydrodynamics. You can see that there's a vortex here, there's a vortex here, and you can even see kind of like the sort of licks of something spinning around here. But there's this area that's maximally affected, which has a center point here. And then there's this sharp line around the outside, and outside that, it's effectively not damaged at all. And this is coming from the outside in. Now, the interesting thing is, from the center of this is the one that's behind. So this effectively is the North Pole. It's coming out here and going through, because this piece of metal, when you look at the live breakdown of the reactor, that bend was in the center of this. And so it comes through there, through that bend, and there's no damage on the underneath. So we know that the flux was coming through that way. And if we actually look at the SEM of that, we have this structure here on the top, this accretion, which looks like a storm. I called it a storm. And so thank you to Alan Goldwater at his Magic Sound Lab for providing access to his SEM. You can see around the outside these little Evo pockmarks here of different scales on the actual Cantal wire. But this actually has calcium in it, which is not in the quartz and it's not in the alumina. And so, you know, there is iron, there's like chromium and aluminium in Cantal, but there isn't the calcium. So this is a typical thing that you see synthesized. So the overall structure that I was looking at here is you had a monopole. The monopoles can link together. They can be born by charge separation, and there is a flow. And in this image down here, we have this 1950s image. You have these things going, and then I'm showing you the two structures there. Okay. And just because it's necessary to do this, because it will be for the next presentation this evening, in this paper in 2006, the Leonid Ezekiel and his colleagues here, Georgi Loshak and Rakhadze, they talk about the paramagnetic bound state of these monopoles into paramagnetic oxygen, and I talked about that in other work. Okay, so the first structure of great importance was the monopole structure in the birdie, as I call it, in the work of Lion in the crust that I use for my remote view logo. And then the second one was those overlaid structures, you know, overlaid kind of like that, actually like that, on the crust, sorry, on the fused quartz coming out of the Lion reactor, because that showed me that there is a flux loop between them of something, which is very similar to what is being talked about here between the black and the white hole, the point of electronuclear collapse, and so on. And it also showed me that it's in line here with the magnetic field of the solenoid. Okay, so you have north, let's say I've got north over here and I've got south over here. It aligns like, I guess maybe it would go south to north like that. It would be like that. Yeah, okay. So I've got north over here and I've got south over here, and the monopoles are aligning like that. Okay. Alrighty. Okay. Is there anything else I want from this one? Okay, so do I want it from this one? So Solon observed these same structures here in his 1992 paper, and you can see them up here, these exact structures, and he refers to these as these monopole structures. Where have I got it? Here. Magnetic solitons of two different polarities in the resulting magnetic superconducting liquid. Magnetically contaminated particles generated and accumulate with generation of superconducting currents. Electromagnetic, nuclear, and gravitational forces are combined with the formation of coherent radiation. And magnetic charges that automatically arise and maintained in its volume lead to the decay of protons and are catalysts for nuclear reactions. With increasing concentration of magnetic charges in the active medium, the intensity of the course of the nuclear reactions increases spasmodically. This is achieved by creating conditions for self-compression of the mass of superconducting nuclear condensate. Magnetic nucleation of magnetically charges particles in it, and generation of coherent radiation, nuclear phase, blah, blah, blah. The combination of electromagnetic, gravitational, and nuclear, blah, blah, blah. Okay, so he talks about these, maybe I haven't got it in this one. It talks about production of these solitons, which are gravimagnetic rotors. So I'll just see if it's in this presentation. If it's not, Give me a second. Ah, there we go. Okay. So this is the key phrase from his patent. Magnetically contaminated particles are generated and accumulate with the generation of superconducting currents. Electromagnetic, nuclear, and gravitational forces are combined with the formation of coherent radiation. Active centers whose shells are composed of superconducting nuclear condensate rotate. They have a magnetic and gravitational field. Thus, active centers act as gravimagnetic rotators in local zones. In the areas of their accumulation in the active medium, superconducting current, eddy currents, and circular waves with white glow, pulsations, and local explosions, orderly directed self-accelerating mass flows in the form of cone and cylinder arise. Okay, so the important thing here really is they have a magnetic and gravitational field. And you will see that it has to be this. It has to be this as we go forward. So I compare down here these structures here with the ones that he is referring to there. Okay. All right. So that's probably enough from that particular presentation. So we'll put that one to bed. Okay. And we'll do this one. So this is from presentation Gravity Transformation on the 9th of November 2022. So this is the latest image from the Phantom Galaxy. And we will go through a couple of slides here. So this is also from the Lion reactor. We've got a 3-spiral galaxy here and a 2-spiral galaxy. Now, every aspect of this, bearing in mind this was way back in January or February, I think January, when I originally wrote the Ode slides, 2018, I had seen this in the Masaryk University here in Brno in the Czech Republic. So thank you very much for the Masaryk University for giving us commercial access to their SEM. Not everyone wants to do that. And the very interesting components here, which I needed an explanation for and didn't until later, was the fact that we had these 2 holes in the center, that we have this zone around the outside which seems circular, and then beyond that we have these 2 beams, and the beams are offset, and they're offset at an angle different to the angle of these things in the center. So that was all very interesting. I've added a slide here from Suhas Ralkar. This was taken by Me356, so thank you very much Me356 or Thomas Tadezhenek for doing the SEM here on his SEM. This was on March the 28th, 2017 that this was done. So this was looking at the material from Suhas Ralkar. I think it was in 2016. But anyway, you can see these 2 spots in the middle and the spiral coming around there and the spiral coming around there. So you've got a spiral and a spiral, okay? And this, I believe, is very similar to what we are seeing here in Matsumoto's 1993 work, where he's got 2 spirals here. We've got a black area here spiraling around and a white area here spiraling around. So there, if I move my mouse vigorously, it might get bigger. There we go. And it's spiraling around there, and this one's spiraling around there. I chose here, I think it's a hyperboloid spiral. I think when you are looking at the big NTOR, depending on the intensity, it tends to be a hyperboloid. I don't know, but it might be when you are looking at the subtors, you're looking at something potentially that is more like a golden ratio spiral, and we will look at that later. Okay, so logarithmic rather than hyperboloid. It does seem to come to a central point, a central point here with the white going around it and the black going around it. This has a black zone around here, and when you actually look at the other images from this, you will see some extra detail. So I'm just going to bring that up. Okay, so you can see that this is super duper spherical. And you can see when Thomas changes the way that it is looked at here, you can still see the 3D nature here of these two lumps in the center. But you can also see this extreme matte kind of look, and I suspect that this is a carbon deposit around here. That this is the main vortex around it, and then there's something going on the outside of this. Okay, again, on this one you can see this same kind of thing going on. There's this area around here, okay, and this is very different from the other more metallic looking things going on. And this is looking at it using the SEM, not the there's one of the backscattering. There you go. There's another close-up of that. Now, I actually looked at this using the Dynalite, and that gives you a very different impression. And this will still be very important. And what you can see actually here is you see something very clearly metallic, but around the outside of that metallic thing, there is another thing which looks different. Okay, so now in this echo experiment, so go and look at the echo experiments. This was something like 2000 volt discharge with a couple of 100 volt DC bias with potassium carbonate, nickel sulfate rather, in water discharges. And so this was a method by which Suhas Ralkar was creating nickel foil for his echo reactor. But you can see these spots. They regularly have this ring around the outside, and then this central zone here. So there's a whole bunch of images here. And this will be important as we go forward. Here you can see the same pattern emerging here. This central area with this ring around the outside. Very different looking materials here. And I'm putting it under different lighting here. This is with no specular. And here actually, interestingly, look at this. This is our kind of pair here in our kind of like vortex shape here. Yeah, and these are at an angle. This is important. We're going to see this angle appear quite a lot. So, okay. So that's a whole bunch of those at different magnifications. Okay. All right. So then I talked about Adamenko. This was in 2018 at my Sochi presentation, and the fact that they had created something in their experiments that was able to consume matter and effectively acting like a black hole, and that it was appearing to be heavier than any known element in the periodic table. In fact, anything that's ever been synthesized, had a mass of 433 AMU. But what it was doing is when they turned off the photon multiplier and turned off the device, they could see an exponential decay from the center. So it was like it was creating Hawking radiation as it was consuming the matter. Okay, so this would imply something that had an incredibly strong gravitational moment. This again is in the LIVESTREAM reactor, and it has this slightly offset, this kind of, I think, a hyperboloid, but it is a spiral of some type going into the center. And for the sake of argument, I put a 4848 3-level Tor here on there that was derived from John Hutchison's fracture sample, our fracture sample from John Hutchison. Okay, and the same kind of offset spiral is here on this work by Bogdanovich et al. At the Moscow Nuclear Physics Institute, where it's slightly you got this little tail. So you've got this little tail here, you've got this little tail here. So I would imagine that the electromagnetic phantom that is producing this core, which is illuminated, is outside of it. So you're seeing the illuminated core, which is the excited matter being collapsed into the gravitational well, this gravimagnetic rotor going into the core here. That's what's going on here, but the actual thing is on a little bit further on the outside. Okay, and these things can cluster, but we're not going to be talking about the cluster today. So the same thing that you're seeing here in the center of this line reactor. And by the way, this is probably carbon or oxidized copper, but given the fact that this is all copper oxide, this is probably carbon deposits, which implies that this is carbon here, or it could be calcium. It could be calcium, because what you're looking at here under the SEM is the darker thing is a lighter element, and both calcium and carbon, and even silicon, for instance, all things you might expect to be in this torus of coherent matter, they are all lighter than copper. Okay, so here this is 40 microns on the John Hutchison MFMP Bullburn sample from 1986, and this is on our aluminium sample from 2007 from John Hutchison, and this is 4 centimeters across. So 40 microns, 4 centimeters across, exactly the same structure. And I think again this is this hyperboloid type spiral. You can see it comes in and then it comes to that radius, it comes in, and maybe it's going to a smaller radius here, I don't know. But anyway, the point is that, and I want you to grasp this point that I'm about to make right now. This is going to be very important for the second of the presentations tonight. This is slightly offset. This is slightly offset. This is slightly offset. Well, this isn't. But these kind of like single monopole structures, they all have this slightly offset side. Offset, offset, offset. Okay. And remember, I thought this was monopoles, and Tom Bearden said, and in the 1980s, I believe that they believed that these were monopoles, and Ken Shoulders said that they form these. In fact, in the conclusion of his book, Evie, A Tale of Discovery, he said they're oscillating monopoles. Well, I don't know about that, but I would certainly agree with the second part of the statement. And in this zone, you can see here, there is total disruption. Absolutely complete 100% total disruption. But outside of it, there's zero disruption whatsoever. Total disruption, zero. Total, zero. Total, zero. Total, zero. There are a number of event horizons on these structures. And this, for me, is one of the key ones, okay? So, like I say, I can't iterate this enough. This slight offset nature will be very, very important for considering what I will share in the second presentation tonight. And I showed how these things can produce these triangles. And here's again the vortex structure going on. This is in the Vega experiment, again in the echo foil production. And these, I believe, are looking at it from a different angle. Okay, so these might be substructures. Okay, these might be sub-monopoles of a bigger monopole structure. I think at the N level, you end up with these offsets. So this would be an N-level spiral. This would be an N-level spiral. These would be N-level spirals. This is an N-level spiral. This is an N-level spiral. It's the core in the center. So, yeah. Okay. Now, from John Hutchison's work, we kind of verified what Archibald Wheeler had said about something, and very specifically he says through the center of these structures, John Archibald Wheeler says that here 2 waves of equal strength run around the torus in opposite directions to produce a standing wave with electric fields strong in regions indicated and magnetic fields strong in the region between. The gravitational field created by this disturbance and required to hold the disturbance together is representable to a good approximation as static and independent of azimuth. Okay, so there we go. So we have a gravitational beam running through this thing. Okay, so here are a whole bunch of impact marks from EVOs on sheaths. Here is a simulation of it. Now, whilst the maximum that we've observed is 48 and in Hutchison's sample, most of them are monopoles, i.e. they just represent as a torus, or they are much less than 48. And so here we've got much less than 48, and often they are much less than 48. I'll go on about the substructure at another time. Here's a physical one in the Vega Valley experiment from Urian.
And here's a model of what that might look like before it got a little bit wonky. Here's another one. And this, I think this one's 24, and you do see fairly regularly up to 24. Now, in mainstream science, they have this coherent matter here, and they say that the coherent matter has gone from an atomic to a molecular Bose-Einstein condensate, whatever that means. So, but anyway, we've got this kind of hexagonal, notionally hexagonal segmented structure here, which is certainly in the realms of looking a little bit like these things here. But anyway, this was worthy of Nature publishing this in April 2021. But, you know, I think Hank's done a much better job with these things. Okay, so that's to do with the subdivision of the structures. But like I say, most of them are 2 levels. Most of them are 2, and the easiest way you can see this is in an ultra experiment. This is not our work. This is bubble structures. I will include the reference for this. This was done at 25 kilohertz. The beauty of doing things at a lower ultrasonic frequency, the bubble structures get bigger. The same thing will still occur, probably even if you're running at 0.1 of a hertz, right? And then the vibration will be much longer wavelength. And so, like, if you had something that was at 4 or 5 hertz, then the scale of the structure would be much bigger. But in theory, it would still do the same thing. And it produces this very interesting structure here, where you have what looks like a ring, and you have these beams coming off, a ring and a beam. Now, this is pulling material in, this is pulling material in. This is pulling material in. We know that because the bubbles that are dissolved so you can't see them are then becoming visible with the exposed light because of the depressurization. So there is a depressurization coming back here and a depressurization that kind of breaks here. Same over this side as well. Okay, and this is what like pairs look like. Now notice that these are they've got a bit of an angle between them. There's an angle there and an angle there, an angle there. Now, I don't know the specific angle that this was filmed at, but we have seen these kind of pairs and pairs of a larger structure in plasma, where you have these things going off at an angle. And that will be relevant when we talk about the second presentation tonight, okay? Out of the core of these things, you've got like a vortex spiral coming out. And we saw this in vibrator plates here by Roish and Amaza. So out of a cavitation spot, which is our vortical structure coming down, this must have 2 substructures in it because we have a twin vortex coming out here. And indeed, when we look at these structures under the microscope, we see lots of pairs of structures here. Okay, so this led me to try and explain what I was seeing here for the first time. We've got 2 spots in the center here, don't know what they are. We've got a circular thing, and then we have some beams coming out. Okay, so I overlaid those by, essentially it depends. If I'm looking at this from one side, it's going to be the flip of the other. So if this is in a clear water cavity, if I flip this, it's going to end up looking like this. And then if I take the original here, I can then overlay that, can't I? Okay, so can overlay that. So that for me there explained these beams coming out here, this beam coming out here, and these 2 spots in the middle. This is offset and angle. It's almost pointing to the corner of that beam. This one's almost pointing to the corner of that beam. But this comes out here, but they're joined together. So there's things going around, but also things firing out. Right. Again, just rotated and on the spiral galaxy out off the James Webb Telescope, it's exact match. It's an exact match. So what this implies is that a fractal toroidal structure like this here, because you've got a toroid here and you've got a toroid here at least, okay? And probably there's toroids going, subtoroids going down there. But it has a gravitational-like component because you are getting exactly the same thing going on, in my view. So here's a summary from this presentation. Matsumoto in 1990 said that in his work it was gravitational collapse of matter. And then he showed these peaked patterns. Solon said magnetic and gravitational field. And then later Shishkin said cavitation leading to cold neutrino condensate necessarily requires gravity capture of neutrinos as only affected by weak force of gravity. So therefore, if you have neutrino condensates captured from the environment, and Shishkin said that his device works for a period of time, this cavitator, which is a water cavitation device, it produces these clusters of cold neutrinos, but after a while it stops producing them. Then he has to move it to a different part of his lab. That implies that it is capturing something that can only be caught by gravity. Okay? So, then the other thing that points to things predominantly being 2 is that most of our strange radiation tracks in our Vega experiments from Henk Uren and David Boutillier have 2. Sometimes they're more. Now, where we see something very interesting here is that when we look into a plasma spot, we see, because of the 14 bits of dynamic range on this wonderful Sony A1 camera and the fast frame rate, we're able to capture this plasma spot, then adjust the exposure so that we can actually see that we've got a spot here which looks like it's composed of 2 spots, and another one that very more clearly seems to be composed of 2 spots, but there seems to be some sort of bleed between the 2. The other thing that you may not notice, you can go and have a look at these images up close, is that these are at an angle again. This is pointing up like that, this is pointing down like that. This is going to be very, very important as we derive this structure. Pointing at an angle, pointing at an angle. And I'm going to, I think, get up a video right now, so because there's something I want to show you in that video, if I've got access to it. Not there. Dang it, where did I put it? Maybe I don't have easy access to it. Did I put it somewhere? Give me a second. Give me a second. Okay. All right. I can't find it. It's one of the videos from my experimentation with Henk Uren. But essentially, when you look in, there's one of these structures which are quite separated a lot. And I will get this and I will put it into the blog stream later. But there's 2 clear, very, very clear spots at a distance. And they are at this angle that I'm referring to. But anyway, you're going to see that later anyway when I do the derivation, but I guess I don't need to show everything. It's going to take forever otherwise. Okay, so we will go back here. Okay, now the other point which is very, very useful to consider is this video, again from a Vega experiment called Tungsten Chop Shop. Not that one. And I need to press play. And I need to go through, and what we did here is, have I got it here? What happened in this video is, when it was building in this experiment, you can see here that opposite, there's a ball lightning here, and there's a ball lightning over here, and it's pulsing with the pulsing from the periodic DC discharge, and it's opposite, okay? And it takes a couple of pulses, and this is greatly slowed down, and eventually it just literally clean chops the material in half, okay? And what we showed during this work was that you could have, and this is going to be very important for the second presentation I will show tonight, is that you can have a ball lightning glowing, and it can glow all day long, but when it has the right amount of energy, it will cut, and it cuts on the double there, on this boundary sphere. That's where it cuts, okay? And it's basically has a threshold. So it's there, you can have the ball lightning, it's glowing all day long, but when you push it over a certain level of intensity, it's an event horizon event. It's a critical threshold, and it just goes like that. And whatever the matter is, it gets destroyed. So you can have something you can't see, an electromagnetic phantom, like in the Bogdanovich work, but it produces a plasma thing in the core, okay? And matter is being transmuted and manipulated in that. You can have an environment where the overall sphere, whatever that is able also to glow, but it's not doing any damage. And then when you push that over a certain limit, that itself gets to the point of being able to disintegrate matter. Okay. All right. So now the next point I want to make here is this magnetic field here, and we're going to show later what I believe is going on here. This is mostly zinc oxide and a little bit of copper oxide, and this is zinc and copper. All of those materials are diamagnetic, which means they want to get away from an intense magnetic field, okay? So I'm arguing that whatever was the cause of this sphere, this iron-rich crenellated iron and oxygen sphere, oxygen being paramagnetic, iron being ferromagnetic, and the combination of this FeO2, the highest proportion of oxidation state of iron that exists so far discovered in nature, at first discovered in China in 2017. This has something around it that is causing this diamagnetic material not to get anywhere close to it, okay? So, you know, if this was water and you wanted to cross an ocean, you know, or a very large body of water, you could create a device that didn't vaporize the water, didn't kill anyone, but you would be able to walk across the ocean with that, because water is diamagnetic and it would push out of the way. Okay, just something for your thinking there, right? So in this instance here, this was another Henk-Uren-Vega experiment, but you can see here there is a hole of material removed, and there is a hole of material removed, and then there is a triangular structure coming down here. And what you're actually seeing here is a 2D representation of the action in 3D that occurs. So in almost all instances, it will be 2. And, you know, it takes a lot of effort to get a lot of the same type of clusters to come together to do what was occurring in Henk-Uren's work, which I showed earlier, where you are having clusters of a large number of different clusters, like here and here and here and here and so forth, and to do what John Hutchison was doing. But for most instances, it will be 2. It can't be 1, although a 1 would be an N level, but with less subcomponents to it, right? But a overall structure needs to be a yin-yang. I mean, if it's a yin, there's going to be a yang somewhere. Okay. But you can have a collection of these things together, as we saw in the John Hutchison work and as we saw in the Henk-Uren work. Okay, these physical manifestations and their footprints on material. Okay, so that's probably all I want to do from that one. And then we're going to talk about what I showed on mining sweeping. Okay, so in mining sweeping, I talked about some of the clustering types that go on here. So you can go and look at this presentation another time. Again, I referred to this, but here was an earlier presentation. So I'm going to go play on here. There was a 5-point structure on here, and there was a 4-point structure on here, like the auspicious symbol. Okay, and this was notified by, in the fact that the 4-point structure here was noticed because there was never any photons coming back from it. It was always black. It didn't matter what element you chose, right? Which is weird. This one over here, it showed the wrong elements. And by that, I mean the spectrum weren't the correct spectrum for the elements they should have been. And this is something that you find because the magnetic monopoles go into and bind to the material, and they change the spectral lines of elements. And this was observed by Xu and Zhu between 1988 and 1999. So when I show this map over here, this one here, firstly, you can see these paisleys. I call them paisleys, but these are the eaten material in that structure of that Bogdanovic structure, or that structure that we saw on the work of John Hutchison. But if I go through this a bit, this is what I like. There are a number of yin-yang structures around here. Okay? And the interesting thing about this is they are kind of like, you know, this is it above or below? It's not. It's not to the side. Okay? So this implies that you've got 5, but then each one's got 2 around it. Okay? So you can get an idea of what the clustering is with these different things. Okay? Now, when it comes to the different numbers of clusters you can have, so this is 5 around it. We've showed a 4 here, okay? We showed a 3, and we showed a 2. What does this look like in copper? Well, in this work, we saw on this ball lightning cut piece of copper, which I actually have in this drawer here. So it's for those that haven't seen it, it looks like this. It's like that. So there is a 15mm ball lightning structure here that cut this hole, okay, in this material. Now, what I'm saying is the same thing happened here that happened with the tungsten, okay? Nothing happened, nothing happened, nothing happened. You can actually see this on the video, right? Nothing happened, nothing happened, nothing happened, and then it completely, immediately, instantly cut this cylinder out. So if you wanted a technology that was able to do something in the center and do some work for you without taking a huge chunk out, you would keep it deliberately below a certain threshold. But that's not to say that on the boundary layer you wouldn't want to be there. It's still going to be a lot of coherent matter, a lot of thing, but it's the whole thing is not one coherent blob. So, you know, anyway, what we're looking at on this screen here is just off to the side of that, and they are multiple structures. So when you have 2 substructures here, like here and here, you get this same kind of structure that we saw on John Hutchison's work. Yeah? Okay, same kind of structure. So here in the center, you've got the same kind of like paisley mark. Okay? That is with 2 on the substructure. Here we've got 3. Even on the 3, you've got the same, little bit like the same sort of paisley in the center. Yeah, but it's a little less vortical in nature. What we're going to look at in the second presentation tonight is going to be a 2-Tor structure. A 2-Tor structure. So that will necessarily mean that the disruption zone below it will have an offset tail. It will have an offset tail. Okay, so please, I can't stress that enough. Bear that in mind. Even if it was 3 Tors, it would have an offset tail. And with 4, it starts to resemble a circle, although it's looking a bit more like a square. It's almost like you've got 2 offset tails, and they're coming in and making a square shape. Okay? Here, we've got 5. Okay? There's 5 around this one. And then here, we've got a 6. And when we get a 6, we start to get a hole. We get something like this looks a bit more like a hole. Okay? And this one I think is 8 around the outside. And it's when you start to get multiple, then like you then start getting other structures going on inside. Okay, so you can imagine as these go up, there's a sort of sub kind of vortexes that go on inside, and that might explain what we're seeing on the line structure. Okay. Now, in terms of what this means for the beams coming out, I already showed what would occurs on here when you get these vortices, okay? But in our David Boutelier's Vega experiment, this is 3. And in Roy Schneemaser's thing, I think this is also 3. And this one here, which is a coherent matter wave that is collapsed, and it's given these lovely diamond structure here. I think this may be 4 or 5 interwoven vortex structures, okay, collapsed into a diamond structure, okay? So it's something like this, but with more of them. So what you can imagine is that the structure that formed this wasn't just 2 like this one, it had another substructure around it. Water tends to form 2 because it's the easiest thing to form. It's like straight yin-yangs. When you're doing electromagnetic, you might get multiple going on. So we got 3, but I think it's a lot more work to go to 3 than it is to just do 2. And we see this many, many, many times. And just for those that haven't seen it, these are the ones that led to finding out the 48 structure which we gave here. Okay, so in John Hutchison's system. Okay, so I think we will be able to explain all of those things using the 3D model. And also one of the other things I'd like to explain is this, where we have a circle, a sphere, and then we have some beams coming off it. We only have the beams coming in one direction. We have a sphere here and beams coming off, but the beams have a finite distance they travel to. They do not go any further. They're from here to somewhere over here, okay? From here to somewhere over here, okay? Why? Why does this have a distance to which it travels and then it does not go beyond? Why does this sphere emit something, or something's coming in? It's either going out or coming in, but it's in a line, but it's only in one direction from this sphere. I think we are going to have an answer to that tonight. Okay? Right. And I just want to note right now, we've got 69 concurrent viewers, which is the first time I've looked at the concurrent viewers in any reasonable sense. And I just think that's a wonderful number for tonight. So thank you very much for those people that got us up to 69. Okay. All right. So, and so just to clarify what this is ultrasonic fuel for Suhas Ralkar's reactor. He gave this to me in 2017. And I looked at this. This fuel scares me. I want to do a gas analysis. I've got another presentation I need to do on this. I think there is synthesis of a particular element, particularly fluorine in this case, in this reactor. In this fuel. And I think it's producing it even today. But what I know is every time I open this vial, I get a few fumes that smells like bromine or fluorine or chlorine. And it irritates, and it's like it's literally eaten the inside of my nasal passage out. So I try to avoid it. But I think it's still highly active, and I'm not surprised given that they have these structures in there. Okay. All right. Okay, so now what else do I want to do? So I think what we've done is we've done evidence for the basic structures, evidence for the cluster structures, evidence for the overall toroidal structure having a non, how should we put this, a non symmetric spiral. Like, so what am I saying? I'm saying this. So it's an offset structure. An offset structure. This is going to be very important. We've shown that you get the material lined up in a row, where in the line structure you've got the things going in the B field and so on. And that's all going to become very important for the second presentation tonight. So I've just got to be conscious of the time because I want to go through the 3D model and variations of it, and also get to ready for the show you that it is a monopole and explain some of the key features going on. So, okay, let me just see what else I want to say here before we start going into the model. I think what you're going to find is that everywhere around you, I'm interested to see what people find once they see what I have to share tonight, because I think they're going to find quite a lot. Oh dear. Okay, not that. Like I say, today in this presentation, I just want to keep it to data that allowed for the derivation of the... okay, so I think I want to do that, don't I? Yes, I want to show that. So give me a second. Talk amongst yourselves. Not there. I'll do that in a separate presentation, but it's not necessary today. Okay, I have much better images of this, but I will share this just now. So this is in a Mars cavity. This is on the steel plate. So the steel plate looks like this under the SEM, and it's half. I think it's actually a full steel plate. No, it's half. Half of it is cut down here of an Amasa vibrator plate, and I'm looking where this blue cross is in this cavitated area here. I think I've got, yeah, so there we go. And I didn't want to do that. I wanted to do that. Okay. And so we've got like, here we've just got a basic cavity group here. Here's one of these heart-shaped pairs where you've got material being eaten away here, and it looks like it's slamming it down over here. So that is a vortex structure, probably. And this is the group that we are going to be referring to, but we're going to go into a lot more detail with that. But the very interesting thing about these cavities is predominantly they are hemispherical. Predominantly they are hemispherical. We observe the same things, but when we are looking at the ball lightning or the balls of fire in the terms of the 2001 Japanese paper on Vega experiments, these self-organizing spheres. In this case, it's a hemisphere that's been chopped out of the steel, and I think we're going to find out why that is occurring. Let me just show you what I mean by the hemispheres on a Vega experiment. I mentioned, just as an aside, I mentioned earlier about ball lightning breaking up. And in the Roydskef exploding metal foil experiments, in the Amaza 10 yen coin, remember we have a yin-yang structure, and on the side of that we have a sub-yin-yang structure, and on the side of that we have these micro ball lightning going around and consuming the oxygen and making sulfur, okay, fusing two oxygens to make sulfur. And so you can have a big structure that just makes a big hole, but it doesn't necessarily be doing any fusing. It might be the n minus 1, minus 2, minus 3 level tores that are actually doing the synthesis of heavier elements going on. So it's one way to think about it. Right, now, what was I actually looking for before? I was looking for ball lightning here, so I'm going to go here. We'll do it with this. Okay, so I talked about this, the fact that this shows that they're north and south, and that there's north and north, or south and south, because of the way that the two experiments were done. I think the relevant thing here is this is a sound experiment here, where you have the separation here. But here's the balls that I'm referring to. These are the spheres with this fuzzy area, the coherent matter layer, and the two zones here. Two zones. Okay, two zones around the sphere here. And I have likened that in the past to the structure sitting on the surface, maybe, I don't know, something like this. And I don't know whether it's as right, but like maybe sitting on the surface like that, and it's producing a sphere over the top. But there's this overall sphere around it. But what you can see from this particular thing is it's not chopping the metal in half. It's not chopping the metal in half. So you actually got a sphere sitting there, and it's not chopping the metal in half. That will be important later. There's one other image I really want to show more importantly. Is it this one? No. This one. Okay. This one has a rather nice demonstration of what I'm trying to say in it. He says. And that is here where you can see on the bolt here on the anode in Henk Uren's experiment, you actually have a hemisphere, and it's not chopping the hemisphere, not chopping the bolt up. And here you have a full sphere. And if we go in, you see that the nickel tape here is going through the sphere. It's going all the way through the sphere and even out of the other side. But the sphere locates itself with the outside of the double layer on the tip, and the inside of the double layer is kind of like the extreme at which it goes, okay? But it is not causing that metal to fall apart at that level of intensity. It does when you push it too hard, but not in this particular instance. So that's that. So, and this is from this Japanese paper from Journal of Plasma and Fusion Research, January 2001. It's Sebastian Popescu. Okay, so you can see how these things can wet together and so forth. And there is the contrast adjust. So you can see the spheres there, hemispheres. Okay, but with two substructures in. And I'm saying that these two substructures will have substructures in them. Okay, now with that, I'm going to go to the boys' room, and then I'm going to start doing the 3D afterwards. Okay, so if you just bear with me for a little while whilst I relieve myself. Okay, all right, let me get this up now. Aye. What a complete honour this is. What a complete honour. Okay. Might regret doing that in a second. Don't even know why I did that. Why did I do that? Okay. All right. Okay. Alrighty. So I hope you can see this actually. Might be a bit dark anyway. Let's see if we can see it. Now, the drawings that I've been using in Photoshop are not exactly accurate because I just drew a circle in Photoshop and moved it around to rough it out. These are more accurate. I still need a little bit of work to do, but this is the overall structure. I don't have the third eye and that going on up the top here. Okay, but this is the main structure. Okay, so we have your two big circles, okay, and then your circles at 50% scale, and then radius, and then 50% of that, and so on. And I've shown that these are exactly what you see on the lion, the first pieces of evidence that I showed you. And then the structures from the work of Tesla's Wardenclyffe Tower are D4D, and so you need to take a slightly smaller dimension inside that so that the radius of something here can be divided 4 times across through the center points of that, and that allows you to create a structure, and then you delete one of those and you put one in the middle, and that gives you the central, what I call the chi row, the Christos, the Christ center. This is the Christ center. It is exactly that. I don't mean anything else. That is precisely what it is. Okay. And what I found is that if you take the Sothic triangle down to the base here, and you had another circle and go through the Christ center with the same diameter as that, it goes down and the Sothic triangle meets the boundary of that. And it's really quite lovely the way that all comes together. Okay, and I've shown how this matches to faces and stuff. I'll actually show a bonus one tonight. It's something that I will talk about later, but this is a face. Faces. Give me more faces. Not there. Not there. No, not there. Okay, we're getting there. All right. So I've chosen a skull, very deliberately, by the way, a denaric skull, very deliberately. This is a denaric skull. Okay. And you can see that the sockets of the eyeballs basically precisely fit these. You can see that the outside of the brow is sloped down pretty much exactly as it should be, and that the teeth line exactly fits here. This is the bottom of the sputum here, and the inside of the nasal passages go here. It is literally amazing that our air breathing apparatus is perfect. It's perfect. If your nose is significantly different in terms of your structure, it would just be harder to breathe. It's incredible how perfect we are. And just for the sake of it, here is another person that's got denaric lineage. Okay. So we have a denaric skull and we have a denaric face. Denaric skull, denaric face. Of course, he's slightly offset to one side. Okay. So that's what it looks like on a face. Okay, let's go back to our 3D model, which isn't 3D yet because I haven't done it in 3D, but we'll see. Okay, so first up, let's have a look at the main cone, and that looks something like this. Okay. All right, so it looks like this, and the sphere that you're seeing in there is the point of the disruption zone. But remember what I was saying, when you are at the top level Tor, the disruption zone can be a circular section here, but it goes off to the side. It goes off to the side, okay? This will be very important in the later presentation, okay? So it's a Sothic cone. It's not a Sothic triangle. It's a Sothic cone, okay? All right, so that's kind of what that looks like there. All right. Now, our main Tor is here. So we're starting to see our angel. Yeah. Loving angels instead. There we go. Okay. Now, we need to go and look at other evidence to show that we have seen these things before. And I need to go to my Azizi presentation for the next tier here. So this is LENR in a can. Is it LENR in a can? No, it's not LENR in a can. I need a different one. Bear with me. Give me a second. I'll leave that up there for the minute. You can look at that whilst I'm looking for something else. Okay, well, I need to do I need to describe the bottom bit there for a start, so let's do that. The disruption area I can show with this one. So this is what I have as the sphere. Now it's slightly offset to one side, and in fact one could argue that this isn't properly registered. It should be rotated a bit more. And in fact, this is sort of over here. But it's kind of the central zone. But what is interesting is that when you have this particular vortex here, the material is broken up here. And I've spoken, and this will be very important later, that you see carbon because carbon is a solid and it's the highest temperature, melting point solid. And so that exists there. Now, when this is destroying this matter, ripping it apart, it will also be producing protons. it will be producing helium, and I expect it will be producing oxygen as well as it's tearing this matter apart. Protons are basically left over, but if you're really tearing something apart, that's what it's going to do, right? But you're always going to get some protons. But this will be very important later. So it's tearing that part and it's feeding itself. It's feeding itself, okay? And this would be the principle of, interstellar journey with 1 kilogram of iron, where you are literally ripping the matter apart using this thing, which actually is the technology which you use to propel it. Okay, so that really is the explanation for this sphere in the bottom here. Okay, and that's perfectly registered where it is, and that is also in the correct place according to the ancient Egyptians, which we have talked about, but we're just going to keep it to the hard data today. And the other example for that is in a magnetohydrodynamic system, but a fluid dynamic system, and we showed that with this one. Well, okay, we showed it with this fluid dynamic one. If I get rid of that. Okay. This is a aluminium foil in a ultra experiment that I did. And again, you can see probably I've rotated that a bit too much to the right. This should be a little bit rotated round, and that would force that a little bit over to the left, which is actually more accurate. But you can see the flow is coming up and round and into this one. Okay, flow is coming up. So this is the zone in which it breaks up, and then there's one fluid dynamic one that I need to show, which is not that. Okay. This one, which is in water, and again, it's a case of the bubbles appear because it's being depressurized here. These are all appearing because it's being depressurized. Okay, so it's depressurizing. Okay. The next presentation will be in just over an hour and 5 minutes. So we're going to get there. That's fine. Okay, so that is showing the basis for the circle down the bottom there, and the cone, and this is the N-level tour. But the N-level tour is actually made of subtours, and they're slightly incorrectly registered here. But I will drop those in, and I will take out the main tour here and put it into the background. So these are the N-1 tours here. And this is what's in the Coptic Christian art, so forth. And so this is what you will need for a basic 2. Okay. Now, these themselves will have their cones, and so this is a yin cone, and again it's self-similar. So if you can imagine that this was a ball lightning composed of 2 N-1 tours, when this blows up, it would produce 2 smaller ball lightnings. Okay, so you can start to understand maybe how you get these quantized structures, and that the quantized structures break down into substructures. Okay, now this over here may be able to break chemical bonds. This might be able to break nuclear bonds. Okay, but it might be the third level, for instance, I'm just hypothesizing here, that is able to break subnuclear bonds, like literally rip matter apart. And what is the third level? Well, before we go to the third level, we're going to show the lemon and the apple. And what do I mean by that? I'm going to put the yin cones into the background, and I'm going to actually knock out the main tour, so we don't need to see that at the moment. Okay, so we just got our cones and our n-1 tour. The lemon is the Ezekiel. It is the fish bladder, the Christian symbol there. So if I actually make the main cone not there, you can see the full fish bladder structure. Okay, all right. And this was the central part of the flower pot in the picture with Tesla when he was trying to publicize his weapon to end all wars. Okay, now around that we have the apple, and the apple is the other part of the main sacred geometry. So I'm going to put that on there, and that is this structure here. So you can see here that fits in. It's an apple. Okay, so if I actually put that in the background, it might be better to see like that. Okay, you see how the apple fits in there. Okay. Now, we actually saw both an apple and a lemon in our LENR experimentation. In fact, I think it was Artifact who looked at the massive image and found the lemon. So thank you to Artifact. So I will find that now. If you just bear with me. So this was in the presentation I gave to the Russian community, and also part of my Azizi presentation last year. So on the left we have the apple, and on the right we have a lemon. Okay, and these are both iron oxide type structures, and as you can see, it comes from the sacred geometry. Okay, so we have physically observed these things. This is not guesswork. This is something we physically observed from these ball lightning systems. And this was both on this was in the Vega Valley, and this is found on the Vega Valley plateau from a blown up ball lightning. Okay, is there anything else I want to show from that one whilst I'm here? Not at the moment. We are going to explain this, the exploded ball lightning, I believe, with our iron crenellated sphere. We will be explaining the material spewing out in Matsumoto's experiments, and also our replications again in the Vega Eastern Plateau with material spewing out. And again, we said we explained this, and so forth. So all of these things will be explained. We're also going to explain these kind of things where you have little spherical things taken out with these chewed up areas in there. We're going to be explaining how you get these spheres taken out. This one particularly, this one here, this wonderful sphere with material coming out here. This type of observation in palladium with deuterium by Matsumoto, the sphere sections taken out, and this in the Hutchison effect sample where you've got spheres removed from the material here. Okay, we're going to have an explanation for all of these different things. Okay, isn't that wonderful? Okay. Okay, so back to our model. So we have our lemon and our apple. So our apple is there, and you can see how that works. Okay. Now, I take the apple out for now, and we are going to start looking at the n-2 level Tor. Okay. And one might think that it would look something like this. Like that. Yeah. So I'm going to get rid of the yin there. I'm going to put the yin cone there. So this is actually kind of what it looks like. You don't see the whole Tor when you've only got two Tors there. And one might think it looks like this, but of course we know the fluid dynamics at the third level Tor don't kind of work like this. They kind of work in a slightly different way. And we know, I was talking about this angle where the material appears to, the two spots in the plasmas from Henk Uren's thing, they're off. In fact, I have a piece of brass somewhere. I don't have it with me now, but I shared the image where there was 4 spots and they were at this angle. And it was like a bit of an epiphany for me. So it isn't actually like this. I can show you another piece of data that's very, very critical, which I shared earlier in the week, and I think that's what got the Los Alamos National Laboratory and the US Navy very excited, because the cat's really out of the bag now. Can't really do anything about it now. Sorry, you did have plenty of opportunity to come clean. Right, so okay. What am I referring to? I am referring to this. And I will get rid of that. I'm referring to this. Okay. Which I spoke about earlier in the week. And this is an experiment from, well, myself, piece of aluminium. It's a ultra experiment, and it has a vortex going around that way and a vortex going around that way. This is the peak with the trough, and this is the, oh no, it's the other way around. This is the peak with the trough, and this is the trough with the peak. Okay. And the interesting thing is when we put the sacred geometry on there, there's funky things like this blob here is exactly outside of this central zone. Okay. Right, so something very differently happened here to in here, and we know that that's the case. But what I'm going to do now is I'm going to put on the golden ratio lines. And if you recall, the golden ratio lines go from the center point between here through the center of one of the sides and out to the inner circle. Okay, so I'm going to put those on there now, and you will notice that the this like 6 or 9 or whatever, it depends if you were looking at it from the other side, is starting on the line here, and this material here, which is the synthesized material on this side, is starting pretty much on the line there as well. Okay, what is this telling us? Well, firstly, we know that this is boron. And in this reactor, we basically have aluminium, which is the main substrate here, and water, which is hydrogen and oxygen. Boron is aluminium minus oxygen. And there was something like, in this blob here, you've got like 57% boron, okay? And nowhere else, just here. Nowhere else, just here, okay? Over on this side, there is 0 boron. But there's calcium. Now, what is calcium? It's aluminium plus oxygen. Okay. Now, of course, there's oxygen in the water, right? But this is aluminium minus oxygen. And over here, we've got aluminium plus oxygen. And we know from the Lion experiment that the flux coming round synthesized calcium where there was no calcium in the center of the vortex on the other side. Okay, so calcium is something that gets synthesized. Okay, we do know that there was aluminium on the Cantal wire. So if it was grabbing oxygen from the silicon dioxide and pulling that round and dumping it into the aluminium and creating calcium, that might explain what was observed. We also observed silver. Now, I did try and find it. I will look out for it. I didn't find it. But in an experiment that from Suhaus Ralkar, where he was doing this electric discharge into palladium, when we looked at it under the Masaryk University, one of these blobs had a vortex, and I think it had platinum and gold around it. And I imagine we would have heavier elements up in this point. I only looked here and I looked here. And here there was some silver, okay? Here there was calcium and so on, okay? So there was 0 calcium on this side and there was 0 boron on this side. One would imagine that if there was some boron and calcium in the water and it was depositing everywhere, well, it would be on this side. Both of them would be on this side and both of them would be on the outside, that side. It's not the case. I believe one side is doing electronuclear collapse and the other side is doing synthesis. I believe that one is ripping matter apart and one is building new matter, and even if there's matter already there, in the case there's already aluminium here, it's actually making heavier elements from the matter that is there. So this is the maker and breaker. In fact, it's breaker on this side and maker on this side. Okay. All right. So what I'm going to do now is I'm going to put in our 200 million year old ammonites. There we go. We've got our 200 million year old ammonites here. And what happens is that if you've got material taken from over here and it's coming around and then it goes within the boundary of the Vesica Pisces, it starts to desynthesize. Over here, if it's coming around here and it goes within the Vesica Pisces, it starts to synthesize. Okay? So from this point onwards, inside the Vesica Pisces, on this line, it starts to desynthesize. From this point onwards, inside the Vesica Pisces, as you go through this line here, so I am therefore suggesting, in my view, that actually, not the ARV, not that, where are we? Let me just get the right thing here. I don't want to make loads of mistakes, more than usual. Where are you? Okay. All right. I am therefore suggesting that the Tor is actually here, and it's slightly offset. I've done it differently in the 3D model, but I would expect it to be slightly offset like this. Okay. So, and in fact, it is a bit like the ammonite. It kind of gets smaller as it comes in. So it's not, when you're getting to this third n-2 level Tor, it's not a pure toroid. It's actually squished on the inside because you've actually got the vortical nature coming in. But for argument's sake, I'm just doing it as a straight Tor at this point. So I'm going to take out the ammonite. And so it looks like that. So you can imagine actually where the nucleation point is here, that this Tor part of the Tor is slightly in. And you see this on Tesla's Wardenclyffe Tower. It actually has the plasmas, the plasma balls, going around and coming in tighter. Okay? Tesla absolutely clocked this. And so did nature 200 million years ago. Okay, so actually this structure would be in. I haven't accurately got it on the 3D model for you tonight, but I believe that at this level it will come in. Okay, and so this will actually be a smaller scale Tor at this level as it comes in. And note, this will be important for the second presentation we will be doing in about 40 minutes. As you go down each level, it gets smaller and smaller and smaller. As it compacts in and compacts in, it's not only compacting in this dimension, it's compacting in the depth into the screen. So what does this look like in 3D? Sorry, YouTube are asking me to insert an ad, but I'm not going to. Sorry. Okay, so what that would actually look like in reality, and I've only done it on one side for the sake of today, is it will look something like this. Okay, so the n-2 level Tor will look like this. Okay, and it will be so one side actually. This one would be smaller and slightly inset by the phi ratio, okay? And so, but for sake of argument, I've just left it as it is right now, okay? Okay. So let's build out our thing. We have our yin substructures here. And we have our main cone, we have our main Tor, and we have our lemon, and I'll put my lemon in full, and we have our apple. Okay, so this is where we are at, and to just clarify that, if I turn these off, what we have here is we have okay. We have, if you just look at this one side here, okay, we have a wheel. That is a wheel. And if I turn that one off and turn on the yin level, we now have a wheel within a wheel. Okay, that is a wheel there within a wheel. And then we have a wheel. So we have a wheel within a wheel within a wheel. That's Ezekiel's wheel. Okay. A wheel within a wheel within a wheel. That is what we have there, right there. And so one might rip chemistry apart. So you might think that years ago we were given a sphere, like it's called a Davy something, a Davy thing, and it vibrated and it's meant to boil water. Well, it might be boiling water or it might be separating water. You could imagine that efficient separation of water in some HHO systems is actually occurring because of the vibration causing this disruption point down the bottom of the main cone here. So our wheel within a wheel within a wheel produces a moment that causes a chemical dissociation down there. So I'm stating tonight that I believe that this process can do chemical bonds. And I'm not saying which level of Tor it can be and which level of excitation it can be, but I'm just saying at some level you do chemical. At other levels you do nuclear bonds. And then, maybe let's see this arbitrarily for sake of argument. The wheel within a wheel is doing the nuclear bonds, and the wheel within a wheel within a wheel is doing the subnuclear disruption. Okay, but it could be an arbitrary level, and it could need to be a certain level of intensity. Okay, now I'm going to go back to Photoshop and some of the data that we've looked at, and I'm going to start to explain some of the phenomenon that we have observed over these years. Okay, all right, so hold in mind what I've just said, because that's going to be very, very important for something that we're going to discuss in the next part of this evening's presentations. Okay, so I've got enough time. I think I'm pacing it okay. All right. Well, well done for those that are still with me. Okay. So what do I want to do? I need different PowerPoint right now. Different thing here. Okay. Don't want that. I don't want that. I want that. Don't want that. Okay. This, to me, is a thing of a real beauty. Oh, love it. In fact, the whole thing is a thing of real beauty. Okay. Okay. So, we talked about this earlier, and this is our 2-bar spiral galaxy from Lion. And then this is the bubble structure by a third party. And you've got the 2 spots on the inside of those 2 spots. You place it there and you align our structure here, and you get your material coming out here. Okay, that's the first bit of correlation here. Now, this is the bubble structure that I was showing you earlier. And the reality is here in this bubble structure, and I have shared this at 8K, I think, even. There are a number of these hemispherical structures with like 2 tails off them. Some of them are too distorted. You've got 2 tails here, not perfect on that one. There's one up here which is quite disruptive. A lot of material in there. You've got a tail here and a tail here. You've got a tail, whip tail here, but not really resolved down here. But you have this very nice one here, okay? And I guarantee you that if you've got a piece of steel and you vibrated it at 179 hertz, like we did and we showed on video, you would be able to look at it under an SEM and you would get this kind of thing going on, okay? You can go and look at the video under Omar on our YouTube channel, and you can see the live captured session where I captured this, and you will see others. Okay, so fine. That is what we're going to be looking at in a second. Okay, so all I've done here is I flipped it, and I am overlaying the aluminium. No, sorry, I'm not. I'm overlaying the copper oxide from the Lion reactor. Okay? And if I turn off the Amasa steel, you can see that here, where this little winglet is here, and outside that is where you get this beam. And the beam goes for a certain distance but stops. Where have we heard that before? Goes for a certain distance but stops. Where have we heard that before? Okay, anyway. Again, over here, this is coming out and it kind of abruptly stops here. Let's have a look. And it is on that winglet. And then these 2 center spots are in the center of this structure. Let's bring in our bubble structure here. And there we see how this is starting to fit together. So something dead in the center here is producing these beams that come out. They have a very, very abrupt start. A very, very abrupt start. Okay. And just for the sake of argument, here is our spiral galaxy in there. Remember, the spiral galaxy has even these little bits coming off here. Okay. So I'm looking at this, and actually here's Bin Juan Huang's thing for the sake of it. There's his bar spiral. This is at Taipei University, energy department, and you can see how the bar spiral with the central zone fits in there. Okay. So this is a third party, same stuff, different place. It's incredibly easy to do this experiment. It's Okay, it's not quite nice actually when you look at the comparison between this and the spiral galaxy here. Okay. Nature works this way on all scales. And the implication is, of course, that if we are to assume that a galaxy is held together by gravity, and Shishkin's process necessarily has to involve a gravitational pull, and it's a gravitational process involved with the work of Matsumoto and with Solon, then I would argue that water cavitation is producing gravitational waves. I'm going to say 100% certainly that that is what is going on. In an ultra experiment, you are producing gravitational wave and beams. Okay? Okay. So I was looking at this thing. Okay. And I'm going to go and share one other thing from the other PSD because it's relevant at this time. This is the beams coming out of the sphere in the Echo fuel from 2017. Okay? And it'll be obvious why I'm showing you this. I'm saying that there is our sphere, and if you scale the sphere in the magnetic center, the chi, the chi rho of the structure, so if I get rid of our lines here, you can see our sphere here in the center, and we have this beams coming down here, and the beam, oh my, look at that. Isn't that just exactly like kind of coming from the center of that and coming from the center of that and coming down? These are the lines. And where does it end? It ends here on this boundary line. Okay? So whether that's pushing out or pulling in, I don't know. But what I can say is this means there's an end point here. And so when you look at this and you look at this, okay? These are substructures or whatever. I'm thinking this is a self-similar thing. So if that's the case, then through the n-level Tor, of which this is the center, these are the n-1 Tors, okay? There will be a beam coming out, which is our major torus, okay? Okay? And then there is a central focus beam, okay? And that's actually the n-1 Tor focus beams. But there's still a boundary here in both cases. So it got me thinking, what if I took the end of this Sothic triangle and from the Chi-Rho center, the Christ center, I draw a sphere around the whole thing. What would that give me? That would give me this, my friends. It would give me this. Okay? I'm going to put in our lemon and our apple. And this is the most likely structure, in my view, of the basic ball lightning, the basic exotic vacuum object, the basic Ankh, hi Kim, love ya. This here, really, I would never have imagined that I could resolve this, but this I am pretty certain. And I think you will be certain that this is the case. Now, what does this help us solve? Well, pretty much everything you want to look at, right? So, the first question I had is, I'm actually missing something on here. What am I missing? I'm missing our disruption beams. These are our disruption beams, okay? And they extend out for a distance, okay? Now, if you have more n-1 Tors, the disruption beams will fold round in on themselves, okay? But if you just have the 2, they don't, in my view. And that, I believe, is what is causing, if I can get it, that is what is causing these beams coming out here, okay? From physical evidence, okay? That is the beams coming out. The same thing's going on with these, okay? Now, I took this model, and this is the big boom for this presentation, and I literally could not believe this. I thought, oh my God, seriously? If I get this and I scale it so that the n-1 subtors line up with those bubble structures in the center of that overall collection of structures, it can't be. It literally can't be. This cannot be the boundary of that hemispherical thing that was chopped out of that steel. Can that thing that you see here, when I go to it, this spherical boundary defined by the intersection with the Sothic triangle, can that account for this hemispherical piece of material removed from this steel? We know ball lightning likes to sit in metal half in and half out, unless you're on a foil or a wire, in which case you see the same sphere. My friends, I put it onto the image and I scaled it, and this is what happened. Boom! It is exact. It is precise. It does not miss at all. 100% certainly. The 3D structure of the O, as presented here, and you can see I have the third-party bubble structures, okay? The third-party bubble structures, okay? Moreover, where the cone, where the disruption beam sphere interacts with the n+1 Tor up, that is where you have this straight line coming out. So some interaction between the n Tor and the n-1 Tor leads to this disruption of matter. And you can also see how the bar of a bar spiral galaxy forms. Now, if we had another Tor here, this wouldn't go round and come close to this. It would come round and go more through the center. And if you had 48, you'd have a perfect ring, and you wouldn't have this beam coming out. It would be closed. Therefore, if you wanted to make, let's say, an anti-gravity craft, right, you would actually have more Tors around in the n-1 Tor. But if you wanted to project etheric energy out to another location, you would want to have less Tors. If you wanted to, say, connect an energy grid. If you wanted to connect an energy grid, you would only have 2 Tors. You could fire energy off one way and fire energy off the other way. I cannot overestimate the significance of what I have realized here. This is not new. Any sentient being at any point in the universe will have realized this. 100% certainly, in my view, I can say confidently that this is gravimagnetic system. It has a force shield which took a sphere out of here. Okay? We'll take a sphere out of John Hutchison's materials inside, just as they took spheres out of the work of Matsumoto, just as they took a sphere outside the diamond in the center of Lion, just as they took spheres out of the aluminium oxide. In fact, this is aluminium oxide. Yeah, it's aluminium oxide of Alexander Parkhomov, just as they took spherical sections. But what is this, my friends? Why have we got these disrupted areas? These disrupted areas at different angles. What are they, my friends? What are they? What are they? I actually can't believe I missed that. Look, it's actually got a hole in it. Okay, all right. We're going to look at some special things here. But for me, this was one of those moments in my life in this journey where I literally got up and go, oh my God, oh my God, oh my God. This can't be real. And you can imagine as I was getting this thing and I was scaling it down, waiting for these N-1 tours to line up with this bubble structure, which was already aligned up with these two independent pieces of data. In fact, 3 if you include the 4 if the spiral galaxy from the spiral galaxy, and you've got the B2N Huang here. If all of these structures, nature works on every scale, and it's just vibration that is doing it. If you get standing waves, you're going to get this. You're going to get it? Yeah, you're going to get it. And you will be able to precisely and 100% certainly design equipment that will work with this principle. And if it's over-energized, it will literally make matter disappear. Bink! It's gone! It's gone! Bink! It's gone! I cannot overestimate the significance of this realization. Like I say, I believe this has been weaponized. I gave them since 2017, since March 2017 to come clean. I'm dissatisfied. I expect that the attacks will get a lot harder and more intense. But this has been a deep honor and a pleasure to share with you. And tonight we are only just getting started. This is civilizational changing stuff. If you are inside this thing, there were certain places I'd want to be. There's certain places I wouldn't want to be, right? But you will be able to create something that is impenetrable to all ordinary matter. Which means if you had a craft where you are correctly putting the streams round, like you had, let's say, 48 segments around here, and you were correctly taking the flux through the center and getting it forced through, I don't know, say, let's say Mercury or whatever, okay, then you would have a zone in here. You might not have any consciousness or experience of time, however, you would be absolutely impenetrable. Nothing. You could fly through the planet Earth. You could fly through water, through space, through air. It literally would not matter. It would not matter what the prevailing weather conditions are. Nothing at all. Nothing at all would be able to damage you, would be able to get in your way, or anything. It would literally disappear at the point it hits this structure. Okay? So, if you want to use this technology for other purposes, don't energize the internal structures too much. Do not energize the internal structures too much. Okay? There will be a point at which it will destroy everything. Okay? All ordinary matter will cease to exist. This is, my friends, 100% it's certainly, in my view, the God's toolbox. Okay? All right. So I'm going to show you a whole bunch of things now, and it becomes fairly trivial to explain most of the unexplainable. I've already done this one from the Echo fuel. We explained why this only goes a distance. It only goes a distance because it only goes a distance. There's a distance it goes, and that's the distance it goes. Okay? Right. Oh, what a pleasure. What a pleasure and an honor. And I can tell you, screen grab this template right now, and just go and look at anything. Just go and look at anything. Any classical building, any classical architecture, classical artifact. Yeah, and if they know what they were talking about, or the mystery schools had taught them, or the secret societies had taught them, but they still didn't know what it was about, this is what they would have seen. Always. Oh dear. Oh, what an honor. What an honor. Here you go. There you go. Screen grab it now. When I've got it there. There you go. Ta-da! This is rough. It's more precise on the other one. Okay. Civilizational changing. And I'm only getting started. What an honor. Okay. All right. At ICCF 22 in 2019, Slobodan Stankovic shared HHO on carbon. And it produced, of course, it would produce silicon and carbon coming out of one end. And it looked like this, my friends. Well, what happens when we put our structure over it? Well, it looks like this. Now, this might be mirrored because it might be the case that some of these splots here are actually the beam coming through from one of the sub-tors. Okay? Okay. I've got a whole bunch of these. Oh, dear. Where did I put them? Where did I put them? Okay. So here's another one. This is from my Seek and Share presentation to the Russian community in 2018. This is the sphere removed from diamond in Lion's reactor. Lion 1. Lion 2, actually, I think. Lion 2. And this image was taken on the 15th of February 2018. And here we go. Boink! And it's a heavier element coming here. Okay? Oh, sorry. Boink! And so just below the apple, and when it comes out of the apple, you get the heavier element. Boink! Okay, we got 19 minutes, so I've got a whole bunch of these things to go through, right? Okay, give me a sec. I'll get some more for you. I actually have a whole bunch of other O-Day slides I could probably do today. Oh dear. So many years. Okay, this is quite hilarious. This, I forget the name of the person that sent this to me, but this is from Ancient Aliens, season 18, episode 16 at 22 minutes. And they retrieved this titanium sphere from a high-altitude balloon, a sampling research device, and it was found under SEM to be belching out carbon, nitrogen, and oxygen from its pole, and they think it is a sign of alien panspermia. No, I'm sorry, it's a ball lightning, maybe atmospheric from meteoroid or something, but it doesn't matter. This is a coherent matter structure, and it spewed out the normal things that it makes: carbon, nitrogen, and oxygen, probably hydrogen as well. There we go. And it's coming out of the weak point, which is the bit where the material, goes in, but it also leaves a hole in the structure as the structure starts to fall apart. So there we go. There's that one. La-di-da. I'm going to go and find that, actually. Okay, it's fine. All right. I didn't want to share anything like this today, but maybe I will. Just this once. No, I'm gonna do a bunch of other of these examples first. How much? 44. That's fine. Fine. Ah, la la la. Oh, what a night. Okay, I need to get this ball lightning fall off. Where is that? Those two. Okay, so we've got two more here. Let's show you these ones. So this one, no, I don't want to show you those ones. I want to show you a different one. Sorry. All right, well, I'm going to do this one. Why not? Because I got it up. So, remember I said I would explain this one? Okay. Well, there we go. It's almost too easy. Now, it might be actually that it's this way round, and the kind of like channel there is something to do with what's going on here. Other supporting thing is if I pull this out of the way, there's kind of like a circle here and a circle here. So we've actually got the apple here. Okay. So I think probably it is that. Okay. But we have the iron-rich crenellated core in the center. This one's 3.6 microns across. And that is our structure in there doing its thing. But alternatively, it can be this way up, with the disruption beam coming towards the camera. Okay, but what this shows is that anything magnetic does not want to be in here. Now, we've shown that these structures themselves can wet together, and you can imagine that around these substructures would be something similar. Okay, so you could actually have an overall sphere structure, but at a lower level you could have these lower levels energized so that they have a sphere around them, a sphere, and this would end up by producing your bead chains, which eat into materials, which we replicated the work of both Solon and Shoulders in that. So you could have an overall sphere being consumed, but you could also have a collection of spheres by having a self-similar structure at a lower level. Okay. Okay, so yeah, it probably is over to the side. Everything else is kind of fitting in there. You've got the slightly offset nature, which we'll talk about more in the next presentation. And you have this fairly clear here structure here. Okay. Late December back in '63. Okay, so that's that one. Let's do another one. Yes, so this is the breakup of the ball lightning, and there's something similar which I will do an example of in that came out of the indium that was exposed to sound and water in our testing with Dr. Royshin Amaza. But this is the one. And of course, we proved that we have there's a little a money roll here of structures here. We proved that there is calcium carbonate, calcium oxide rather, the silicon dioxide, and there is carbon in here, and also all of the usual suspects that you get synthesized from the George Ohsawa ball lightning type spectrum of elements synthesized. And we also showed that the principal elements in here are exactly the spectrum of ball lightning in the only captured spectrum by a Chinese group that was published, I think, in Nature. Okay, so this is a ball lightning overall structure that came and collapsed on the predominantly almost pure zinc oxide surface on the Vega Valley Eastern Plateau. And this is what the colliding structure, in my view, did when it came in. Is it going to show me? It's going to show me. Okay, there we go. So our ball lightning here, the core of the magnetic core of the ball lightning is here, which is hollow. Okay, there we go. And it even looks like you've got the cut-off bottom here. You can see the cut-off bottom there, with it spewing out, right? So this is like a cap, okay? I might have got the angle slightly wrong on that, but you get the idea. So what this implies is that the substructures here are producing the calcium and the silicon and the oxygen and the carbon, okay? And they might have a carbon beam coming out of here and a carbon beam coming out of here. And that, my friends, might have explained the hole and the carbon sphere on the original iron-rich crenellated sphere that I found in the NOVA reactor, which I shared at the beginning of this presentation. And because of the way that this is breaking up, you end up with this kinked wing here, and this broken wing, and this ejectile over here. Okay? This, I believe, is showing the breakup of the structure. Okay? Now, I've got two things to show you. I've got a whole bunch of these, like basically everywhere. Okay, and then I want to show you how you can know that this is a monopole, and then a special treat before we switch streams. Okay. The spheres don't show a ridge around them. No, they are spheres. We've got them a range of scales. Okay, you can see the orbit ring there of something, and you do get that a lot. And I think that's just basically there's a spin moment around here, and you just get a trail of the matter as it decoheres from a coherent state where it's not really any element, and it comes down and leaves these rings around the material. Okay, and that will just be, it's maybe going into the page where this collided or something like that. But there we go. That, I believe, explains that. And I will do the same in another time. Maybe a little quick video to show that the same process is occurring in the indium. Where are they? Where is the image? Give me a second. Oh, where have I lost it? I lost it. Hope I can keep my brain for the next section. Getting there. There won't be a summary tonight, sorry. The whole thing's a summary. Okay, we'll do that last, because it ties through to the next presentation. Okay, I've got a whole bunch of them here. So you've seen this one here. This is from Stankovic's work. Thank you, Slobodan. This is the replication we did of effectively in Vega experiment, Vega Valley. There is a ball here, crenellated sphere, and it's chucking out titanium little discs. And, you know, I think these two discs may actually be the two sub-tors, actually. They've just been spat out. And it's spewed out this carbon stream here. We've looked at that in detail in the past. What am I looking at? I'm going to see if I can find that. It's called Vega Valley Prolapse, isn't it? Let me see if I can find that. Ah, there we go. All right, I can show you that one properly. There we go. Vega Valley Prolapse. Hank, Urian, and myself. And you can see there's one sphere here. See, there is material wrapped around it. Okay. Over here, the sphere has got something coming out of it. So whether that is if this is the magnetic core, then these would probably been around the outside of it, and they just maybe came over to one end. Okay. Maybe they've got their own magnetic moment, and they've lined up with the magnetic moment on the core here, and then it's spewed out this carbon blob trail as it's gone down there. It's gone along. So that's what I think is going on there. It's coming out of that hole there. Okay. So I'm going to now show that this is a magnetic monopole, and then I've got a little. No, maybe I'll do that at the start of the next presentation. Okay. So we will hold that off. Let's keep this all for scientific data. All for scientific data. No speculation on artifacts. Okay, so I need to pull up a PDF. So when my machine dies, because Acrobat for some reason is incredibly resource hungry. Okay, so this is in Nature letter, a letter to Nature. And it's observation of Dirac monopoles in a synthetic magnetic field. I've talked about this in the past, but this was all over the news at the time back in, I think it was 2014, was it? 2000, I think it was in 2014. It was done at a university in Finland. And here are the structures, and we're going to be looking at this image, but here is another image of that. So this is the publicity image that they have, where you have the overall sphere structure, which has a monopole location. And here's the monopole location. And note, I have been telling you that these are all types of spin properties. This is spin down on the bottom, spin horizontal, and spin up. Spin down, spin horizontal, and spin up. But it has this monopole, okay? And this was at Aalto University in Finland, okay? And this was classified in Nature as Dirac monopole, okay? Okay, so we're going to overrun by maybe just a minute or two. Nearly there. So what I've done is I've taken that image from that paper and I have turned it upside down because it works with our model better. And you might already start to recognize things when you look at it. On the left, you have the spin up structure. This is the spin horizontal, and this is the spin down, and this is the composite. Okay? And this is the synthetic calculated version. Okay? This is the observed from the fine magnetically manipulated condensate. Okay, superconducting condensate. Okay, here you have the synthetic computer calculated model of what it would look like looking through it, and here is the actual observation. Now note, they have a perfect circle in the middle. Here you have almost like an S shape, Definitely a yin-yang going on. There's a black bit here and a white bit here, and that one's coming round there, and this one's coming round there, isn't it? Interesting. Well, let's see what happens when we put our structure on there. Well, look at that. Look at that. That is our birdie. The central bit around the Tor, N Tor, is the spin horizontal. And this whole zone below, okay, all the way down to the chin line, as I call it, is the spin, the other spin, down maybe. And notice it has this tube through the center, coming up to a central point, which then flips the spin. Here is the top down. Okay, now their synthetic version is a pure circle in the middle, but it's actually two kind of vortices. You can see it here, definitely. And I've put a yin yang there for the sake of it. Okay, so I think that we can say, looking at this, say, look, this by nature was agreed and peer reviewed that this was a synthetic Dirac monopole. I'm arguing that what we have created is a physical mathematical structure using sacred geometry that better matches the actual observables from the experiment than whatever calculations they're doing to produce this, because their calculation does not do what ours does, which is show why you have the yin-yang structure, as you see here. Okay? Ours does, theirs doesn't. So I think, my friends, this is the model of a monopole, in which case we can completely manipulate matter. And with that, I'm going to say thank you very much, and I will see you in a few minutes in the next stream. See you soon. Join me for O-Day, new dawn of an old age. You don't want to miss it.